Hello everyone, and today's topic is electromagnetic induction. So basically, what even is electromagnetic induction? It is basically the current which is induced due to magnetic field or electric field. Basically, you know the word electromagnetic induction, the current induced by electromagnetic fields, and basically it's due to the effects of magnetic field in any resistance wire or object or any wire in general. Okay, so what even is magnetic flux? So basically, in order to get the value for magnetic induction, or basically the induction value or EMF or potential difference, you need to first get what is magnetic flux. Magnetic flux is basically the amount, yeah, basically the number of magnetic field lines which are passing through a cross sectional area. It is basically the dot product of B and A, basically the dot product of magnetic field or area B dot A or B A cos theta, and basically this gives us the value of magnetic flux. So basically, if this is any object and these are the magnetic fields passing through it, the value of flux comes out to be ba cos theta base, and it comes out to be dot product. So there is also cos theta. So for example, there is a special case if the object lies parallel to the magnetic field, then the cos theta comes out to be 90, and basically then the value of magnetic flux comes out to be 0, and that is a very special and unique case, and there is a reason that it has to be perpendicular so that it passes through the so that the magnetic field pass straight through the cross sectional area, and then the cos theta comes out to be 0, and then the value comes out to be ba, or simply magnetic field into a. But in general the correct formula is b dot a or ba cos theta, and this gives us the value of uh, magnetic flux. Now, what gives us the value of potential difference? Potential difference is basically caused due to the change in magnetic flux with respect to time. Now, what even is like change in magnetic flux? Basically, suppose this is the any object wire or cross sectional area, and I've rotated it through 180 degrees. So basically, there is a change in magnetic flux because there is a change in the orientation of the object in the given space. Basically, the cos phi changes even though the area remains same. The cos theta changes, and hence there is a change in magnetic flux. And this change in magnetic flux with respect to time is what gives us the value of EMF. But this is only by the Faraday law. Now there is a difference. There is a Lenz law which also accounts for the direction of the EMF. Now, Lenz law basically states that the induced EMF, basically the potential difference which is induced due to the magnetic field, opposes the motion of magnetic field itself. Basically, it tries to reduce or stop the magnetic field or current or anything which comes in, and the EMF, or basically through the Lenz law, it tries to stop it and acts against it. Hence, the EMF comes out to be minus of the change of magnetic flux with respect to time, and hence the formula comes out to be V or EMF is equals to minus d phi by dt, where phi is the change in, where phi is magnetic flux and d phi is change in magnetic flux. So basically, now that you have attained what the EMF is, there is another way to get the magnetic current, basically the current induced or induced current, and it also opposes the the magnetic field lines, and it acts in opposite direction. So the value of induced current comes out to be minus d phi by dt multiplied by 1 by r. Basically, if you apply the V is equals to IR Ohm's law formula, and you get the value. Basically, you know how we got V is equals to minus d phi by dt. You apply the same value of V in V is equals to IR, and hence you get like the value of induced current. Now, what is the units of magnetic flux? It comes out to be 1 Weber, which is basically 1 Tesla into 1 meter square. So basically it is Tm square, pun intended, for RF. 1 Weber is equal to 1 Tm square, and 1 Gauss is 10 to the power minus 4 Tesla, and you can then calculate the value, and you know how 1 centimeter square is equal to 10 to the power minus 4 meter square. So if it is given in CGS units, you can calculate the value in standard or SI unit form. Now the next topic is the motional view of current, motional EMF. So basically, what is motional EMF? It is basically when the given object or wire or any standard is moving inside a magnetic field. For example, this bottle, for example, it is moving in a magnetic field. What will be the EMF induced by it? So basically, you know how we learned Lorentz force in previous chapter. So basically the same concept applies here, where F electric field is equals to force by magnetic field. So it comes out to be E is equals to VB, and hence you can calculate the value of E, which we know how. Okay, so basically E is equals to B times V. So, and E is basically E is equals to VL. So the value of V, or potential difference, comes out to be BLV. Hello, I don't know why I said that. So basically the V comes out to be BLV, and hence you get the value of potential difference, which is caused by motional EMF, or we know the potential difference induced by magnetic and electrical field. And you can also calculate the same value of induced current by applying the value of V in the Ohm's law, which is V is equals to IR. And since you have gotten the value of both I and R, you can also calculate the value of force and power. Force is, B, B square L square V by R. And how does we come to this conclusion? Basically, you know how in previous chapter magnetism, or we learned that force is equals to BIL sine theta, and since the value of sine theta is 90 degree in these cases, the value comes out to be BIL. And now that we have the value of B, I and L, the value of I, by applying the value of Ohm's law, and you know how we got V, and how then we get the value of I, and we apply that value in the same equation BIL, where B, L and the value of I comes out to be BLV by R, and hence the value of force in magnetic field comes out to be B square L square V by R. And simply we can also calculate the value of power by the same logic, because power is equals to F dot V, which is the F V cos theta, and here cos theta is 90, and we here the value of cos theta is equals to 1. We don't really count for that much here because we are not into that. The value of power comes out to be B square L square V upon R into velocity, which comes out to be BLV whole square upon R. And what is BLV? It is the value of V. So we can also write it V square by R, and we can also, technically verify the formula of Ohm's law, by which gives P is equals to V square by R. Okay, damn, I did not know that. I just realized that. Good thing teaching, gang. Now, I think that is most with like this chapter. I'm pretty sure there really is nothing much in this chapter. It's a pretty short chapter, and yeah, I think the only topic left is self-induction. Yeah, it's basically uh, okay. So basically, self-induction is when in a circuit, for example, there is a circuit and current is flowing through it, and you have like L value, you have it there. So what happens is the current produces an induced current which opposes it by Lenz's law, of course. The current itself produces an induced current which opposes it, and the value of the the value, there is a like resistance in given equations and things, and same way there is a capacitor. There is also an induction inducer which is also given here, and there is a specific like thing, an object, it's made of that, and by that we can give rise to that. For example, phi is equals to Li, and the thing is d phi is actually given by L d I by dt, and we can also calculate the induced potential difference through this formula. But you know how potential difference is equals to minus d phi by dt, and we have phi is equals to Li, so we can put the value here and we get v is equals to minus L di by dt. And that way we can also calculate induced current when we just divide the given equation of potential by resistance, and we can get the value of both induced current which is generated by current itself, and the self-inductor. Okay, I'm so thirsty, gang. I'm gonna end it right now. I'm so thirsty, gang.